This is my Kinematics Reassessment, Chapter 4, number 73. A ball is thrown horizontally off the edge of a cliff with an initial speed of 20 meters per second. A. How long does it take for the ball to fall to the ground 20 meters below? How long would it take for the ball to reach the ground if it were dropped from rest off the cliff edge? How long would it take the ball to fall to the ground if it were thrown at an initial velocity of 20 meters per second, but 18 degrees below the horizontal? Okay, so for the first part, you set up your one of your kinematic equations. Change in y, or position of y, is equal to the initial velocity in the y direction times change in time plus 1/2 acceleration in the y direction times delta t squared. So because it was thrown 20 meters above the ground, your change in y is -20 because final minus initial. So your final position would be 0, your initial position would be 20. So 0 minus 20 is -20. Your initial velocity in the y direction is 0, so that automatically cancels this out. So then you're left with 1/2 times acceleration in the y direction, which is 9.8 meters per second, because gravity is the only thing acting on it, and delta t squared. So you get -20 equals -4.9 delta t squared. So you divide by 4.9 on both sides, and then you do the square root on each side, and you get -20 divided by -4.9 is equal to change in t, and then delta t is equal to 2.02 seconds. Now, part B. How long would it take for the ball to reach the ground if it were dropped from rest off the cliff edge? It would still take the same amount of time because the initial velocity in the y direction is 0 for both times. Therefore, the only force acting on it is gravity, which is the same. So it'd be the same, which over here, 2.02 seconds. And then for the third part, how long would it take the ball to fall to the ground if it were thrown at an initial velocity of 20 meters per second, but 18 degrees below the horizontal? So draw a picture. You have your 18 degrees below the horizontal, and you need to find an x and y component of each. And so SOHCAHTOA is how I remember it. Some old hippie caught another hippie tripping on apples, or acid is the explicit version. So for the y direction, we'd have sine of 18 degrees, and then in the x direction it would be cosine of 18 degrees. So you take your kinematic equation over here, and you get change in the y position is equal to the initial velocity times sine theta, which is your y direction, delta t, plus 1/2 gravity delta t squared. So your y position again is -20. Your initial velocity is 20 meters per second. And sine of theta, or sine of 18 degrees, change in delta t, not change in delta t, plus 1/2 9.8 meters per second squared, delta t squared. So once you distribute and move everything around, you get 4.9 delta t squared plus 20 sine 18 degrees delta t plus 20 is equal to 0. So in order to solve this, you need to use the quadratic equation, -b plus or minus square root of b squared minus 4ac all over 2a. And so you come over here, -b, -20 sine 18 degrees plus or minus square root of 20 sine 18 squared minus 4.9 times 20, and then 2 divided by 2 times 4.9. And then once you do the math there, you have 1.5, you come out with 1.5 seconds. You come out with two answers, but the other answer was a negative, and you can't have negative time. So the positive answer is your answer, 1.5 seconds.